So let's take a look at compound interest again. Say $500 is invested at 7% compounded annually for 5 years. So we use our spreadsheet to do this. And we're going to take 500 and multiply it by 107%. And that's because we want it to grow by 7%. So we get the spreadsheet to repeat this pattern, and after 5 years we have $701.28. Suppose we wanted to calculate this just using our calculator. Can we do this in one step on our calculator? Well, what did the spreadsheet actually do? It took 500 and then it multiplied 500 by 1.07, and it did that 5 times. Repeated multiplication is just a power. So if we use a power of 5, we get to multiply it 5 times. We get the same result. So that means we could make a formula to answer questions like this one. So we have our amount, which was the 700 and change, and the principal, which was our $500. We had the 1 for the 100%, and we had 0.07 as our I, and N was 5 years. So that's a formula that we could use. So let's say we take $500 and it's invested at 6% for 5 years. Compounded semi-annually. So semi-annually means every half year. So it would happen in the middle of the year and at the end of the year. So for 5 years, that's going to happen 10 times. So we're counting in half years. And we're not going to get 6% every half year. We're actually going to get half of that. So once again, we repeat the pattern using the spreadsheet and calculate the final amount. We could do the same thing using our calculator in one step. Remember, it's exponent 10 because it's 10 half years. And we're getting the same result, $671.96. Now suppose we were to do this quarterly. Same amount of time, same dollar amount. So in 5 years, we would have 20 quarters. I took 5 and I multiplied it by 4. So this time I'm not going to increase it by 3% each time. I'm going to increase it by 1.5%. So a quarter of 6%. And you'll notice we're actually getting different values. We're getting more money because we're compounding it more frequently. So again, on the calculator to review, so what I had done is use the same idea. Another way I could have shown my work I could take that 6 divided by 4 and then raise it to the power of 5 years times 4. Interest can also be compounded monthly. So I'm going to count by months. How many months are there in 5 years? Five times 12 gives us 60 months. Now I'm going to take that $500 and I'm going to grow it by 0.5% each month. 0.5% because 6% divided by 12 is 0.5%. And I repeat that 60 times. So if I wanted to calculate this value on my calculator, so what we notice is in our original formula, we had an I and an N. When we compound the interest more frequently, the I changes, gets smaller, and the N gets bigger. So we need a new formula for this. So we're going to use R. That would be our 6% M is the number of times per year. In the case of monthly, that would be 12, and so we would divide our rate by 12, and we'd also multiply our T by that number as well. So in the last example, that would be 12 as well. 12 times 5 gave us the 60.